I'm going to demonstrate how to use inverse matrices to solve this matrix equation. So let's designate this as matrix A, and this matrix X, and this as matrix B. So we've got, these are the unknowns. Now I can't divide by matrix A, that doesn't exist. But what I can do, if it exists, is multiply both sides of this equation by the inverse of matrix A. So I've done the same thing to both sides. If the inverse of matrix A exists, this should become the identity matrix, multiplied by X, inverse of A times B, and the identity matrix times X just leaves matrix X. So this is how I'm going to solve this equation. I'm going to see if I can find the inverse of matrix A, this one, and then I'll multiply that by matrix B. So first of all, inverse of matrix A. The inverse of matrix A is 1 divided by the determinant of matrix A, and then we have D and A swap places, and we have negative B and negative C. The determinant is AD minus BC, D, negative B, negative C, A. So remembering that this is A, B, C and D, AD would be 3 5s are 15, BC 2 7s are 14, well that's fortunate, and then we would have the 5 here, the 3 here, and we'd have negative 2 here, and we'd have negative 7 here. Now why did I say that's fortunate? Because 15 take 14 is 1, 1 over 1 is still 1, and so the inverse of matrix A, nice and simple this one, and there it is. So now to solving the equation. Matrix X, the unknown, should be the inverse here, 5, negative 2, negative 7, 3, and matrix B from the top was 12, negative 4. So we would have 5 times 12 is 60, plus negative 2 by negative 4 is 8. Then we'd have negative 7 by 12 is negative 84, plus 3 times negative 4 is negative 12. So I have 68, and I have negative 96. That's the solution to my matrix equation. Now, as long as I did my sums correctly, did my arithmetic correctly, I should be able to check the solution of that on the calculator. I'll just start with a 2 by 2 matrix, and I'm going to enter the original 3, 2, 7, 5, and then I'll have a 2 by 1 matrix, and I'll enter my solution. I thought it was 68 and negative 96, and what do I produce? 12, negative 4, which was what the question required. So I've verified the solution, and we now know the value of matrix X. It's a 2 by 1 matrix, 68, negative 96.